Welcome to yet another video on SRA Cloud. In this video, I want to extend my previous video. I did one on inter VRF natting using Cisco VASI, and in this video, I want to extend that the same video, but I will not ask you to watch that video to come here. I'm going to repeat everything so that this video is also self-contained. So in this video, I'm adding one more aspect to this topology, and that is another network, and that network should not go through natting. It should go through BGP, some other path. So here is a requirement for this video, and let's get started with this topology that you're seeing on the screen right now. The 10.140.45.0 network at the bottom of this topology has two compute nodes, and these two compute nodes should be able to talk to the external network around the external router on the right side of this topology only one way. That means PC1 and PC2 should be able to access PC3, but PC3 should not be allowed to talk to PC1 and PC2. Think of our home network where we have phones and iPads and various compute devices behind the firewall or router or switch provided by the internet service provider, and through that we can go to the internet, but that this design does not allow anyone from the internet to come back into our device, home devices. So the same thing simulated here. So PC1 and PC2 will go out and talk to PC3 in only one way, and that is accomplished with the natting in the edge router, which we will see. We already saw that in the previous video, but I'm going to repeat that. And on top of that, I want to have another network, 10.140.50.0, and that is supposed to be bidirectional, in the sense the PC4 on that network will be able to talk to PC3 in the external network, and PC3 should be able to talk back to PC4. So that is the bidirectional access. So in this topology, the requirement is to mix both one-way as well as bidirectional traffic all through the same core router and edge router and external router, and of course a couple of switches in this topology as well. So let's get started, and let's look at the 10.140.45.0 network. So let's go to PC1. This PC1 has IP 10.140.45.0, 45.0 network, and its IP is 10.140.45.2, and its gateway is 10.140.45.1, which is on the core router, which we will see in a moment. And now let me go to PC2. Same thing, 10.140.45.3 is this guy's IP address, and its gateway is 10.140.45.1 on the core router. And then we are going to look at the switch, the ESW1, which connects both PC1 and PC2 on a VLAN 1000. Let me, for the sake of clarity and also completeness, let us see VLAN database and show. So it has VLAN 1000. This is what we are concerned about at this point for 10.140.45.0. And let me get out of this. Show IP into brief. So here the F00 and F01, they are on VLAN 1000. So these are access ports, and F02 is the trunk port. And since we are on ESW1, let me also talk about PC4. And PC4 is 10.140.50.2, that is its IP, and then 10.140.50.1 is its gateway on the core router, which we will see in a moment. Okay, so back on the switch, the F03 is also a access port with VLAN 200. So let's take a look at the running configuration on this route, on this switch. Here it is. 00 is on 1000, 01 is also on 1000, and 02, which is going to the router, is a trunk port, and 03 is on VLAN 200. So that's pretty much on this switch, and of course there's a VLAN and all that. Okay, so now let us look at a core router. So this is the core router. Look at the running configuration of that. So there is a VRF A, and its route descriptor is 65999:1, and there is a port channel 1, and this port channel 1 is on the gigabit Ethernet 1 that is to the switch. So we have a port channel on the southern side of the core router, and this port channel has two sub interfaces, 200 and 1000, with the appropriate VLAN IDs. Both carry the same IP. 10.1.40.51 is for VLAN 200, and 10.1.40.45.1 for VLAN 1000. These two act as the gateways for the corresponding networks. And then there is another port channel 2, which is towards the edge router, and there is a sub interface 1000 on it. And interestingly, it does not have a port channel for 200 on that. It's only one. And its IP is 172.16.16 going to the edge router. And the second port channel is attached to the gigabit Ethernet 2 physical interface through the channel group keyword. So 3 and 4 are not used at all. And here is the BGP on the core router connecting to the edge router. So 65999 is the ASN of the core router, and 66999 is the ASN of the edge router. And there is a BGP rule under VRF-A. The neighbor is 172.16.15 on the edge router, and 172.16.16 is on the core router. And I also have a route, IP route VRF-A, under the VRF-A, a default route to the edge router. So let's do some ping operations here. Let us see if we can ping all the IPs. First of all, let us look at the, let me move this to the right. Oh, sorry. Let's look at the routing table. Show IP route, nothing on the global, and show IP route VRF-A. There are quite a few routes which I didn't talk about until now. So, for example, this one 10.1.40.12.128, which we will see in a moment. So this is the routing table on the VRF-A. Interestingly, importantly, 10.1.40.45 and 10.1.40.50 are on it. They are directly connected to it. Okay, so now let's do some pinging. Ping VRF-A 10.1.40.45.2, that works, and .3, that works as well, and then 10.1.40.50.2, that also works. So all three compute endpoints on VLAN 1000 and 200 are accessible from the core router under VRF-A. Okay, now let's move on to edge router. Let me minimize a little bit so we can see the edge router. Okay. So there is a customer VRF on this one. The customer VRF is on the interface towards the external router. And there is a usual VRF-A on the southern side towards the core router. and I'm exporting and importing the route descriptors across from VRFA to customer and customer to VRFA. So this will facilitate route distributions from VRFA to customer and then customer to VRFA. So this is required for the 10.140.50 network to be accessible in bidirectional way with the external router. So let's proceed further. There's a port channel 1, and this port channel is on the gigabit Ethernet 1 towards the core router, and the port channel 1.1000 is on it, and it's on VRFA. That is the southern side of the edge router actually, and the IP address is 172.16.1.5. We already saw this IP as a neighbor in the BGP environment on the core router. So gigabit Ethernet 1 has this channel group 1, and the gigabit Ethernet 2 is the right side connectivity to the external router, and there's no port channel on it. There's no need for that, and this interface, the physical interface, is directly placed under customer VRF. The IP is set to 10.140.12.141. This belongs to the 10.140.12.128/25 network. Later on, for NATing purposes, we are going to derive an IP from this network and then move on. And here is the interesting part. Must have seen in the previous video the VASI left and VASI right. The VASI left is under VRFA and VASI right is on the customer VRF. There is a transient network 10.1.1.1 and 10.1.1.2 on these two interfaces, VASI interfaces. And here is the BGP. So here the BGP is both ways, because edge router has a connectivity, southern connectivity to the core router, and a northern or sideways, right side connectivity to the external router. So both are defined here. For the customer VRF, the neighbor is 10.140.12.129, and a remote has 67,000, which is the ASN of the external router. And similarly for the VRFA, it is connected to 65999, which is the ASN of the core router, and 172.16.1.6 is a neighbor for that. And then I have an access list, and in this access list I am permitting only 10.140.40.50 network to be NATed. So I have added the permission from 10.140.45 network to my external host 10.140.11.4, because it is my intention to go there through NATing. And here is the pool. I derived, as I said earlier, I derived a 10.140.12.150 IP from the network between edge and external routers, and it's called pool. And then here is the source NAT, overloaded source NAT definition. The NATing is done on the customer VRF. And then there is a default route to 10.140.12.129, which is the IP of the interface on the external router. So anything from the customer VRF, if it does not know where to send it to, it will be sent to this IP. And there is another route in the customer VRF to the VASI right. So this is to enable the connectivity to the VASI left and right setup. And then there is another route on the VRFA to go to 10.140.11.0 through VASI left, and then 10.140.12.128 network through VASI left. Both of them are on the VASI left. Okay, so this setup is required to do NATing across VRF from VRFA to customer. And that's it on this edge router. And now let's go to external router. On the external router, let's look at the running configuration. The external router network is very, very simple. There is no port channel, there is no VLAN, there is no VRF either. So it's very straightforward setup over there. Gigabit Ethernet 1 is connected to the edge router and it has IP 10.140.12.129, and Gigabit Ethernet 2 is connected to the switch, the external switch, and its IP is 10.140.11.1, which acts as the gateway of the 10.140.11.0 network on which the external network is. And 3 and 4 has got nothing. And here is the BGP between the external router and then edge router. And this is the setup. And in this, the neighbor is 10.140.12.141. Okay. So that is, okay, and then of course there is a route to 10.140.45.0 network through the 141, 10.140.12.141 interface for the return trip to come back. There is something I forgot to tell you on the edge router. So let's go back to the edge router again. So if you look at the BGP, this one, I'm not using redistribute connected here because I do not want to distribute 10.140.45.0 a network over there. If I do that, then that will become bidirectional. That is not my intention. 10.140.45.0 is supposed to be outbound only, one way. So the other network, which is supposed to be bidirectional, 10.140.50.0 network, is explicitly mentioned here. So only this route is pushed to the external router from the edge router. I think this is the very important aspect of this design. Okay, and then let's for the sake of completion, let's look at the second switch. There's nothing fancy over there. And let's look at the running configuration. Fast Ethernet 00 is connected to the PC3, and there's no VLAN or anything like that. And then Fast Ethernet 01 is connected to the external router, and there's nothing on that either. No VLAN or anything like that. So now let's look at PC3, and its IP is 10.140.11.4. So this is the target of all our ping tests. Okay, now let us see from 10.140.11.4, which is the PC3, I should be able to talk to 10.140.50.2 through the BGP. Ping 10.140.50.2 and is able to talk to it. Now, since I already mentioned that the 10.140.45.0 network is supposed to be outbound only, PC3 should not be able to talk to PC1 or PC2. So let us try that. 10.140.45.2, it will not work. And if I try .3, it should not work either. Okay, so now let me go to PC1 and PC2. Let me do the PC1 first. I should be able to talk to PC3. I think I already did this here, and I'm able to do that. Wait a minute, I will show the Wireshark to prove that this traffic is actually using NATing in a moment when I complete the PC2 and PC4 ping tests. So from here I'm able to ping 10.140.11.4. Okay, let's quickly go to PC4 and then make sure it can talk to 11.4 as well. And is able to do that. Okay, now let me go back to PC1 and keep it ready on the left. I'm going to attach a Wireshark between edge and external router. make it a little bit tiny. And I will be doing focusing only on ICMP. Okay, now where is PC1? Okay, so from PC1, I'm trying to access the PC3. And as you can see in the Wireshark, the source IP got replaced from 10.140.45.2 to 10.140.12.150, the NATed IP address. Okay, and now while this is still there, let me go to PC4 and see what happens when it tries to talk to 11.4. And here no natting is used. The IP address 10.140.50.2 is used straight away. So I think this proves very well that we have a couple of things going on under the same topology, which is the requirement here. 10.140.45.0 under the VRF A is able to use natting to go to PC3, any outside network from through the edge router. And you should not be allowed to come back in the opposite direction. But 10.140.50.0 network can go outside and access the PC3, and PC3 can access the 10.140.50 network as well through BGP, because that route got distributed, but this 10.140.45.0 did not get distributed as intended, and the natting was configured on the edge router to accomplish the connectivity. So I hope you enjoyed this video and at least able to understand how to put together a couple of a variety of access mechanisms or route distribution or whatever, however you want to call it, into one topology, because customers may want to create a network like 10.140.45.0 network that should be one directional, and 10.140.50.0 network that's bidirectional. So I think this kind of design will let the customers have the flexibility. Instead of creating a whole new VRF and whole new environment, a parallel environment, the same can be used, same VRF can be used to house both 10.140.50 and 10.140.45 networks, and then accomplish the flexibility. So thanks for watching, and I will produce a lot more videos very soon. And have a wonderful day or afternoon or evening, and bye for now.